Okay, welcome everyone to the fourth Civo community meet. We've got some great talks coming up tonight about machine learning and open policy agent. So hopefully everyone enjoys it. If you have any questions, feel free to pop them into the Q&A section of the Zoom webinar, and we'll either get the speaker to answer it as we go, or we'll ask them at the end if it would interrupt the flow too much. And again, feel free to use the chat. We appreciate any reactions and comments as we're going. So first up tonight, we have Saiyam, who's Director of Technical Evangelism at Civo, talking about machine learning on Kubernetes. Then we have Alessandro and Gabriele talking about machine learning pipelines on Civo. And finally, finishing up with Alex Jones talking about open policy agent. So I'll hand over to Saiyam for the first presentation.
Awesome. I'll share my screen. Okay, you should be able to see the screen now, hopefully.
Yep, all good.
Awesome. So welcome all for the webinar, and today I'll be talking about machine learning on Kubernetes. So machine learning is complex and Kubernetes is not easy. So when they both come together, it's super hard. So you have to be super technical, you know, awesome in machine learning and awesome in Kubernetes to understand this talk. Don't believe me, I'll make this talk as simple as possible. So I'm working as Director of Technical Evangelism at Civo, and let's get started. So we'll go. Today we'll be covering what is ML challenges, ML on Kubernetes, Kubeflow, and a small demo, not that much, but I just want to show the UI. So machine learning is everywhere. So from your day-to-day activities to whatever you do, whatever you order, whatever you listen, machine learning is everywhere. So you take Spotify, you get predictions of the songs, your favorite songs from all around the artists, and you book Uber, you get the nearest rider, you book Airbnb, you give a rating. Next time when you come, you'll get recommended, recommended listings from the other users who rated the same one. So like this, there are other predictions that are doing. You go to shopping online, you buy some product, and when other people have bought the same product and whatever they have purchased, so you will be shown that as listing on your screen. And obviously it's not that easy. So they have additional complex algorithms and ML models that they have developed so that you get very curated list of your recommendation. So also when you order food, so basically ML is at all levels. So you take any day-to-day activities, any organizations, people are doing ML, they want predictions, they want recommendation systems. So everything is there. So what is ML? What is machine learning? So basically, the first thing over here is human teach human. So think of a baby, and we teach baby how to walk, and then they develop a skill. We teach them how to ride a bike, and then they develop a skill. So basically we are training them and they are developing a skill. So the similar kind of approach is used when we talk about machine learning. So humans, basically now what we do is we create a model. So we have a training data. So we use that particular data, make it very insightful, and a lot goes into that particular aspect, the data aspect. That is the main one. And then we create a model, and we do predictions, and then we learn more. We try to train it more with the test data for the accuracy and all the other stuff. And the end goal is that it itself, our application or the end goal, will develop a skill. So basically what you call AI. So AI is skill like learning, machine learning on its own. So that's the end goal of any ML pipeline or any ML process. So basically this is how in short I feel, from data, making it valuable and converting it to a skill is all about machine learning. So you have training data and another insight of that. So training data, so you do the training, you create a model. So model is just the code that you write and the algorithms that you use to generate some insightful results from the data that you have. And then you have the output, and then based on that output you do the predictions. So very simple example, you can have a simple application where you upload a picture and it'll tell you which animal it is. So like this, it's everywhere. And now ML like I told you, it's not simple and it has its own complexity. So this is one of the diagrams from the Google research paper. So the ML code that you can see in the middle is this much. And you can see what all things has to be a part of a full machine learning workflow or pipeline or whatever you can call it, a ecosystem. So you have the configuration, you have data collection, data validation, tagging, classification, all these things. And then on the infra side, you have your machine learning resource management, analytics tools, the infrastructure, and then the monitoring on top of it. So there are a lot of aspects when we talk about machine learning as a whole. And there's a very small piece over there, which is the ML code that a machine learning engineer will, people will say that, okay, he's developing models. But no, there is a lot of other things that has to be done in order to implement that model and make it work and serve it in production. So you have different languages, and machine learning has evolved over time. So it's not like the frameworks have evolved. There are different frameworks to choose from. The languages have evolved, different languages to choose from. There are devices that you can run: CPUs, GPUs, TPUs, edge, on-prem, all these things. So you have R, Python, Scala, and you can, PyTorch, scikit-learn, TensorFlow. Like I told you, all the devices that you can learn your make use of doing this ML processing, training, serving, and all these things. So now what happens is we should why Kubernetes? So why machine learning on Kubernetes? So we all know, and if you don't know, I'll just brief you about it. So containerization, eases out the process of, application dependencies and everything packaged inside single code. You can use different binaries, different versions of an application, and all those. So that's containerization stuff that you can do. And Kubernetes is the orchestrator, and it's having its own set of powerful features. Now, when we talk about ML on Kubernetes, we say that there are basic things that we are looking for, which is composability, portability, and scalability. You must have heard this, and if you have watched any of the Kubeflow talks. So composability is basically you have the microservices, and microservices integrate very well when you talk about the Kubernetes ecosystem. It's extremely portable because you have the base layer already ready, and you will be able to switch your workload from on-premise to cloud or to from your laptop as well very easily. And then scalability, yes, Kubernetes have scaling capabilities, and whenever you are writing a model and then your training data increases and your model goes into production, then there is a scale that is required, and Kubernetes can handle that very well. And other things like related itself. So auto scaling, resource control, multiple tools, like you have monitoring, logging, you can use service mesh. So all these things can takes the advantage. So these are the Kubernetes advantages. So machine learning will be able to use all these advantages very well. Now you have machine learning, now you have the ecosystem, now you have the base layer, the compute layer all set with Kubernetes in place. So okay, I have Kubernetes in place. Now what do I do? Now there are a lot of things apart from it when you talk about ML workflow, when you have to develop, deploy, and manage the model. And that's where Kubeflow come in. So Kubeflow is something that is built on top of Kubernetes. So anywhere that you can run Kubernetes, you can run Kubeflow. So you have a base layer of Kubernetes, and you have the Kubeflow layer on top of it, which is containerization machine learning ecosystem. So you have everything containerized. It's a containerizing machine learning platform that helps you to develop, deploy, and manage your complete machine learning lifecycle. So there are different aspects to it. You have data validation, you have evaluation, you have model training, you have model serving. You can do all. So it provides you a complete package to do all the machine learning tasks that you need. And it gives you a concise, like it gives you all the frameworks and everything that will go the next. So this is what it looks like. So it's based on operators. So like kubectl is the command when you run all the kubectl things on interacting with the Kubernetes. There's a similar binary called kfctl that you will be using when you want to install Kubeflow on Kubernetes. So with KFCTL, you can provide configuration files where you can actually tell whether you want to use PyTorch, whether you want to use TensorFlow. So all these things. So everything is configurable, and whatever you need to choose, you can configure that, and Kubeflow will be a ready package. So you can have PyTorch serving, TensorFlow serving, Silden core, and you can Dockerize it, Dockerize your machine learning workloads, and most importantly, you have a UI. You have Jupyter Notebook integration, which is very good. So because you don't need your laptop anymore, I would believe, if you are just doing very big training. So you will be just having Kubeflow installed on any cloud on Kubernetes infrastructure, which has a huge scale of CPU and GPUs attached to it. And then you will be running your Jupyter Notebook. So it's powered by Jupyter Lab. So your Jupyter Notebooks will be there, and you can share it across the teams. You can have different workspaces. So all these things will be there. So you can write the code, your model over there, and test out all the training data from the storages. So storage is also another aspects that Kubernetes can take use of with respect to different cloud vendors. And it's platform agnostic. You can run it on any of the cloud platform. And then you have Kubernetes, and then you have the all the ML tools. So it gives you the extensibility and the power to use any of the ML tools that flexibility. Sorry, any of the ML tools. So you can use any of this like they are mentioned over here. Now, apart from this, you can take the Kubernetes capabilities, which are Prometheus, Argo, Istio. So all these capabilities obviously comes with Kubernetes. So you can use those capabilities as well. So before this, I would like to show a demo as well, which is, I hope it works. So basically, I have already deployed Kubeflow on Civo managed KTS cluster. So this is the whole Kubeflow running. Though the thing is, like, when you deploy Kubeflow, you actually have to deploy a YAML file and configure, do some configurations, and it's very important that you understand that. Else, it will not deploy properly. Though you will be running some aspects will be running, because it exposes as a service, and you get your Istio ingress. So some aspects will be working, but if you do not specify the right parameters, and it won't be a full-fledged working. So make sure you do that, and you can check out all on the documentation. So this is how the Kubeflow UI looks like. You have you have homepage. Pipelines I'll not touch, because pipelines are something you will hear about more in the next talk. Kubeflow pipelines. So notebook servers, which is very interesting. So this is what I was talking about. You can have a new server, and you can name it test, and you can choose image already. So there are pre-baked images. You can bring your own image of different flavors, and you can specify the CPU, and you can specify the workspace, add volumes, and also shared memory in GPUs if you want to add. So, and you can click on launch. So behind the scenes, it's actually creating a pod, which you will be seeing over here, and then you can connect to this particular pod, and it will basically open a Jupyter notebook. So it's running, and no healthy upstream. So we'll wait, maybe. Yeah, so so this is the Jupyter notebook, and I have it. I can create the file. You can see all the things over here, which is very good. Also Kubeflow, let me go back to the home. There's cat-tips, which is there for hyperparameter tuning. Now, when you create a machine learning model, you have to define the accuracy. You have to have the hyperparameter tuning so that you can define certain parameters, and you have to identify that. Then you can predict the what you call the accuracy, so that you can see how much accurate the model is. And cat-tip is there to help you on that. So you define what all the parameters are that I want to tune my model to, and then you can also increase the accuracy of that. So all in all, this is the high level overview of machine learning, why machine learning on Kubernetes, and what Kubeflow is and how it looks like. With this, I think I'm done for this particular talk. So any questions, just let me know in the chat, and with that, I'll hand over to you, Andy.
Cool. Okay. So I think it's my turn now.
Yep.
And yeah, so let me start, because and thank you, Simon, because there's a lot of stuff that actually you presented that is really interesting for me. And there's a couple of questions there that actually I will try to answer as well. You should see my screen, I think. In the meantime, I saw a couple of questions that I was really interested in from Walid and Sana. So Walid, he was speaking about the difference between the parallel jobs that you can run on top of a high performance computing and using Kubernetes, where you cannot run in parallel the same task spread the same task over the nodes. But actually, you spotted right that there's a new MPI operator under the Kubeflow. So actually, we try to achieve that with as a community. Now, there's a bit of difference still between Kubernetes and high performance computing. I would say that, at least that's my opinion. The typical use case is you go for Kubeflow and Kubernetes when you go for recursive tasks, especially around training. You need an all-in-one platform where you can basically spread from the notebook up to the operators, to the serving, to the trainings, and the pipeline for the training and so on. While instead, when you go for high-performance computing, typically you go for a highly dedicated task that need and then look for highly performance computing and powerful computing for that. Now, Simon did a great job in, let's say, show Kubeflow as if it is really simple to be installed and to be used. Now, don't trust him. No, jokes apart. Actually, Kubeflow is pretty simple to install, but it's all in one. You basically cannot choose between the various pieces of Kubeflow. You get everything. And the problem is it comes to the Susanna question about the resources. To install Kubeflow, you have to have a minimal of 12 gigs of RAM just to bear basically minimal installing that. And if you even just try to attempt to deploy a notebook and the pipeline and so on, it will grow and grow. So it's not really meant to run locally. And it is even worse if you are in a CI environment where actually you have to do the use to deploy Kubeflow, test a training model, and then destroy the environment. It's not really fit the story. So this is where my story with Gabriele starts. So let me explain you a couple of things. I'm a product manager. I'm responsible for AI at SUSE. He's an amazing developer, and actually is actually the only humankind that actually willing to listen to me every day because I really talk too much. But we have different needs. He's knowledgeable. He has everything. He knows everything when it comes to let's say DevOps kind of use cases. So he knows how to set up a CI/CD kind of environment. He knows how to set up Kubernetes. He knows how to set up everything from an infrastructure standpoint and develop microservices and a beautiful application there. I come from a world where let's say I'm Art, the data scientist on TV, but actually I know how to build a model. I know how to use a framework like TensorFlow, but I mostly don't know anything about Kubernetes. So we have different needs with different challenges, because you want to learn AI platforms, you want to learn how to use AI platform, maybe develop on top of them, and you want to have them quickly. And I want to have my platform up and running quickly, and I don't want to have to spend time how to install and configure Kubernetes and everything together. Now, Civo is already, emerging heaven for that kind of things, because it can give me amazing infrastructure at my disposal, especially on K3s. But our starting point was like, okay, what if you want to run locally or want to run everywhere? So we said, okay, you know everything about K, whether it is Kubernetes, whether it's K3s, whether it's Kind, whether it's any K flavor there. I know a bit of stuff around AI, how we can combine them, and actually they bring this idea about, oh, what about something like K3i? So let's start a little bit again. Kubernetes, the Swiss Army knife of technologies that comes out of a black hole. Now, the problem with the Swiss Army knife typically is that, I don't know you guys, but typically I'm basically find myself looking at the Swiss knife and said, okay, what the heck, why I need this tool and that, and that, and that, and that, because there are too many of them and too many options and too many complexity at some point. I don't want to spend my life learning Kubernetes just to run Kubeflow on top of it. Well, but Gabriele, that was my conversation with him. Like, AI is way more simple. And actually, Sami show something like that. Okay, this is from the Kubeflow community. And trust me, Kubeflow is one of the simplest things to install. This is just the flow that you go to install all the things that you see on the right of this slide. Do you have a single node deployment use case, a cloud deployment? You go for a local deployment. You already have Kubernetes. You need to deploy Kubernetes. Once you got that, okay, these are all the things that you need though. But wait, I just want to have MPI operator and pipelines. I don't want all this stuff. How can I install the single stuff? And all this stuff is single manifest. You need to learn customize. You need to learn kube control. You need to learn everything. Well, I don't know you, but I'm not that kind of guy that actually is going to spend days or weeks just to do that. So can we make it a little bit faster? No, maybe it's because we are Italian, maybe because we are coders, but I don't know what you read in this slide, but typically I know my ideas don't come from, but I know they comes out of too much coffee in my life. So how can we make this simpler? And me and Gabriele thought, okay, maybe let's say that we put some, let's say, goals. And our goals is that we want to have everything up in less than 3 commas, possibly, or no more than 3 commas. Up in 5 minutes. Well, unless you are not sitting in my place, that because of a bandwidth could be longer. But let's say in the normal world, less than 5 minutes. That could be deployed and run on local or cloud. That can be cherry picking whatever you like. If I just need the MPI operator, I want to have MPI operator. If I just want to have PyTorch operator or Argo workflows or Kubeflow pipelines or a Jupyter notebook or H2O or Katib and so on and so on and so on. I just want to have them in minutes. Can we make that? And the answer was yes. And so that's why we built K3i. K3i is a project. We launched the project more or less 4 weeks ago, and we were so lucky to meet Sami and many other guys that are contributing with us. And so we said, okay, one, all you have to do is just take this single line command. We will install everything for you. Second, then you will run K3i init, just in case you don't have anything, and we will take care of everything there, and I will show you how. And then finally, K3i CLI apply, that says like, hey, you can add everything you need from the list that we provide you. Any plugin is there in that. 3 commands, 5 minutes, up and running, job done. I know. Demo anyone? Because, if you don't have a demo, it doesn't really make sense. Okay, let's start from the beginning. And the beginning is, sorry, just a second. Because we are in Civo, let's start from the Civo use case. So I got my Civo account there, as you can see. There's already cluster, but just for the sake of time, but actually, let's start from the init. And all I have to do is just, I want to deploy a new cluster. Init, cloud, Civo, and I'm starting. That's all I have to learn to install a cluster on Civo and then deploy my stuff. I copy and paste. I hope I'm copy and paste the right one. Oops, sorry. I'm copy and pasted the wrong one. Oops, that's here's the stuff. Sorry about that. I thought I got the right stuff. Just a sec. It's not a demo if you don't have at least an error there. Okay, let me just come back here and do again. Oops. CLI init the cloud.civo. And this time we should be good to go. So I was saying like, okay, let's try to install that cluster. And it says, okay, well, how do you want to call this cluster? Let's call it K3i demo. And how many nodes you want on the cluster? Let's say 1. And which size? Well, G2 large seems like good. It's 8 gig of RAM, if I remember right, on Civo. And you're good to go. That means that on my Civo, I should have a cluster there that actually is installing for me. All I need to do is just waiting, grab the kubeconfig, Later, we will grab the qconfig dynamically, but grab the qconfig and I'm good to go. That's all I have to learn to deploy and then starting to deploy stuff there. Now, for the sake of the demo, and I said, I already deployed another Kubernetes. So while he's doing that, we will check back that. Let me check on the other class that I have, this one, K3i demo. And to demonstrate that, I got this slide where I got the famous K9S to show you that cluster. You see, actually, I've got a cluster there. And on the other hand, I can start to play with CLI. First things, hey, what's in for me as a plugin? What can I install there? And then we simply do a list. Now it could be slow because, as I said, I'm living in a place where actually that is not really great. So you got Argo, you got H2O, you got Jupyter that is already been installed there. You got Khatib, pipelines based on Tecton CD, pipelines based on Argo workflows, NPI operator, and so on. And you can even do a group list. So what's the difference between a plugin and a group? Well, a plugin is what it says name. It's just a plugin. It's just that single application. A group is a combination of plugins. Like in my case, I want to expose the pipelines through traffic that is installed on my Civo. So all I have to do is just C3I, CLI, apply -G, apply group, and I want to deploy Kubeflow pipelines traffic. That's all I have to learn to install pipelines. Now you will see that I'm grabbing the upstream manifest from Kubeflow in the right order with the right configuration and in a, oh, sorry. I forgot that I did not have K3s here. And with the right manifest, with the right order, and then in a second or so, you will see that on the right, something will happen on my Civo cluster. That's all I have to learn to install the single pieces of the entire Kubeflow or any application I like on AI tool here that basically solve my needs actually to do everything that I want. So, oh, by the way, this is, okay. It's coming. By the way, I'm just figuring out actually that I got another environment right now. Okay, it's coming, and in a second you should see that appearing. As I said, my life as a bandwidth is pretty interesting, as you can see. Gabriele at this point already deployed like 30 cluster. Typically, the first time we deployed something, it was like, hey, you just need 5 minutes, and I said, 5 minutes, like 40 minutes, there you go, Kubeflow's coming. That's all you have to do. Don't have to wait for anything else. And if I want to install something else, let's say, let's take another list. And let's say that I want to install, I don't know, Khatib. Oops, sorry. Boom, done. I just need to know what I want to install. Now, Khatib is pretty, oh, sorry, again, the same I wrote before. Khatib is pretty interesting because Khatib just not installed simply Khatib. It requires also some operators like PyTorch operator, TensorFlow operator. So you will see actually that I installed them in the right order. Now, there you go. Adding some labels to Kubeflow to use Khatib, deploy, there you go, the TensorFlow operator and the PyTorch operator, and then deploy the 4 Khatib controllers there. So that's the use case. There you go, Khatib. 1, 2, 3, 4, and they're deploying there. In the meantime, let's check the status of our deployment on the other side. Okay, it's still there. Was finishing branding, but as you can see, actually we have a perfect things. Let's try to even understand how much is integrated. That let me just delete my cluster right away, and actually you will see that actually that the moment that actually the cluster has been deleted, I will not get the cluster anymore. Oh, by the way, it was just finished. I did not have in time. So let me come back here. oops, to this presentation. I was supposed to be in the presentation. Sorry about that. There you go. So as you saw, what we've done was, and just came back, exactly what we promised. One single command to start, one single command to deploy the entire infrastructure, and it can be local based on K2S, Mirantis, KidsRS, kind, or it could be cloud like Civo, and apply that actually can grab any plugin and go there. Now, one thing that could be really interesting is could be how much is difficult to write a plugin there. Okay, let me take a plugin. You remember the pipelines? I'm starting from there. The Kubeflow pipelines are simple as a name, plugin EML, and let me just grab this guy a little bit closer. There you go. And the upstream manifest from Kubeflow. So we just take care of that. Now, in case you wonder, the fact that actually Kubeflow works as a charm on anything that is not Docker as a container engine, so anything that it could be containerd or CRI-O, is thanks to Gabriele. His upstream manifest on the Kubeflow community make this. Now you can see actually we can pass a customize directly, but also we can pass, for example, the file capability. Means you wrote your own EML and you just pass them up. Also, you can do it even better than this. If I do something like H, you will see that actually you can even pass a custom repo. Means you can create your own repo, you can create your own plugins and use them or mix them between your own plugins and etc. And that's basically everything you need. You can even, and this is something that actually we are literally building right now. You can even pass a config file. And a config file is nothing more than a simple YAML file that allow you to configure all the needs you have, every cluster you need to create, every application you need to create, so that actually you can literally embed K3i directly within your CI environment. Sorry, I lost the word. So with that, how it works. So docs.k3i.in, we are updating those right away now with the version 2 of the CLI. If you want to contribute, even just you want to test out things, those are the pointers. K3i.core is the Go client that we created. K3i plugins is where we build the plugins. We have a great Slack channel, and you are all invited to join the K3i. The invitation is in the website, on the docs website. As I said, everybody is absolutely welcome to join us, to help out, even just with the documentation or even just with the issue, open issue. Tell us what you need from us, and we will be more than happy actually to help you out. Now, with that, basically, I'm finishing. I know Gabriele did not feel very well today, and I really thank him to be there today as well. If you have any question, we are here, definitely.
Can I add some things here?
Yeah, absolutely, yes.
So one of the common questions here is why should they use K3i and not Helm, Customize, Bash, etc. With K3i, we support Helm, Customize, File, Bash, PostScript all together. So if you want to create some group complex, you can create everything and you can mix all these technologies together.
Yeah, no, absolutely. Well said. Well said. And the fact that also that you can use the local repo is a perfect combination, because you can have it's like a sort of app store. You can have your own plugin store where you can combine different technologies. The fact that you can recreate Kubeflow as a whole by starting from a single point allow you to have enough flexibility. So there was a question about having Kubeflow on the marketplace of Civo. Actually, well, if you want, as an alternative way, you can literally use C3I to deploy everything on Civo directly as a part of a marketplace. Because in the end, we can leverage even some of the applications from Civo to be deployed there. So it's pretty flexible as a tool. That's why actually we deployed it, to try to solve the complexity that we all see in our market. Okay, I'm going to stop the sharing for a while. In the meantime, if you have any other questions, I'm more than happy to answer them. I see a couple of questions. I see a question about Kubeflow is only installable with EML command line file. Currently, Kubeflow leverage a binary called kf control, but actually kf control simply use the EML files underneath. So there's no single binary to be installed. Can Kubeflow handle streaming data like in Spark machine? So Kubeflow as a platform rely on many tools underneath. So Spark could be one of them. So Kubeflow per se is just a combination of tools. So for example, that's why it leverage operators like PyTorch, TensorFlow, etc. So it can leverage Spark underneath. So that's basically the way it works. It's not, a single platform that does everything. It simply is a combination, is a combination of things that could be used. So Spark could be part of Kubeflow as well, could be used in combination of.
Alessandro, did you see Walid's question as well? One concern I often hear about ML in Cube is the lack of advanced scheduling, like in Slurm.
Yes,
so
yes.
ML job does not.
Yeah, I already answered it. That was exactly what I was explaining about high performance computing. So the difference is that Slurm is a scheduler in high performance computing. Kapaliva Slurm is that you basically leverage all the nodes of a high performance computing cluster at the same time to parallelize the job task. What in Kubernetes, typically you cannot achieve that. Now, MPI is one of the capability to operate in parallel. And there's an MPI operator in Kubeflow, actually has been deployed an MPI operator, more generically speaking, around Kubernetes that try to achieve the same use case. The reason is, from one side, because in the high performance computing market, there start to be requested the support for Kubernetes within high performance computing cluster. On the other hand, actually to have the same parallelization within Kubernetes.
Thank you.
Yep, you're welcome.
And then just one more. We'll come to the other ones at the end in the main Q&A.
Yep.
If Kubeflow requires 12 gig on Kubernetes, does it require 12 gig on K3S as well? So
if you install the whole Kubeflow, yes, that is a requirement from Kubeflow. So it doesn't matter on where it runs. That is the requirement for the whole Kubeflow. And that's the reason why me and Gabriele, we thought about, let's say, slice Kubeflow and allow you actually to install Kubeflow by modules. So using only the things that actually you care of, because this way we can reduce the size of the RAM demand. For example, if you just install pipelines, that is well, let's say the bigger component of Kubeflow, it will require anyways 8 gigs. But actually, we manage. It was a joke in the Slack channel one day, but I managed to have the pipelines running on top of a 2 gigs RAM edge device. Now, of course, you cannot really do anything with that. But if it is just to learn Kubeflow pipeline, you can literally run them on top of a 4 gigs RAM device.
Perfect. Thank you very much.
You're welcome.
Okay. If there are any other questions, feel free to add them, and as I said, we'll get to them in the final Q&A. But for now, let's hand over to Alex Jones, who's going to talk about Open Policy Agent.
Thank you very much. Let me just share my screen. Let me just preface this with an apology. I was deciding it was a good time to rebalance the radiators before this talk, and so I have some fiberglass in my lungs and I'm coughing a bit. So I'll do my best to drink water and carry on. So thank you very much, first and foremost, to Civo team for inviting me to speak tonight. I hope that you can see my screen. One of the things I'd like to talk to you about tonight, in fact, let me just, Yes, just double check, is Open Policy Agent. And the second thing is how it's being utilized at enterprise, and what are the sort of problems that enterprise organizations, fintechs, are actually going through right now. So here's some firsthand experience, and hopefully it will be interesting because OPA is a very interesting project, but it also underlines some of the major architectural problems that need to be solved when utilizing cloud native technologies in traditional landscapes. So without any further ado, in this abridged version, I will just give you a quick who am I. I'm an engineering director at American Express. I work out of Victoria normally, and I have a team of SREs, cloud engineers, and other practitioners who help to keep the lights on for internal frameworks in the organization. So it's an interesting role. We do a lot of observability, tracing, microservice architecture, things like Istio, Google Anthos, and other jazz like that. And more recently, I've started working on how do we make our systems work better together. And this is really great because as part of the Continuous Delivery Foundation, as an ambassador, and as part of the DevOps Institute, these things kind of all just click. And so I saw a real kind of intersection of interests with the open source work I do and with the stuff I'm doing for work. So I hope you'll find this interesting. And if there are any more questions, please ask at the end or reach out to me privately. I think you might have seen some links at the beginning. So every story needs a beginning. And this story starts for me with developer experience. DX is a real barometer at the moment of how sophisticated a tech organization it is. It really is the gold standard. When you think of good DX, you think of Heroku. They've been doing this for a decade. You think of other companies like HashiCorp, and you even think of things like the Civo CLI, which are really testaments to how we're thinking about developers as the core drivers for grassroots business adoption and championing. So as such, when I was asked to help improve the DX at American Express and at previous occupations, it became apparent that there has often in large-scale organizations been a problem where you see a disjointed experience, and that experience often is less joy and more pain. And therefore, I decided that the best way to represent this is in a very scientific graph. And part of my background has also been working at startups. And this is typically how I would work in a startup. You join on day one, you have a bit of pain getting set up, but then eventually it's great, right? It's a joyful experience because you have things like a CI/CD process that just works and enables you to deploy out to a production environment very painlessly, right? And it's a lot of fun in a small org because if you see there's a problem in the dev experience, you can just fix that, right? Or someone can open a PR. So usually in the first week, you're up and running. However, contrary to that, in an enterprise organization, this is the DX experience typically. There's sort of an abandon all hope, ye who enter here, when you join an organization, and you'll find by sort of the first month or so, you're really struggling to get just a React package out to update a website. And this is really the crux of where I want to sort of explore in this brief talk. And, this is backed by actual empirical evidence as well as qualitative evidence. So I've used a Likert scale in a survey. And those of you who might have read Accelerate, which has authors such as Jez Humble on it, will know that these kind of psychometric tests can wean really interesting answers out of developers. Like, did you find this experience using Jenkins good, great, or amazing, or terrible? These kind of questions. And what these answers, when you start to aggregate them from a large developer community, is that often you'll find that the experience, the larger the organization, the more painful it is. And I think that just makes common sense anyway. But let's really ask the why of why that is. The why comes down to interoperability. And I've put a big Oxford Dictionary definition, which I found confusing when I was speaking over this last time. So I'm just going to tell you, interoperability is the ability of computer systems to exchange information or make use of it. Essentially, how well do things work together in a single organization? When we think about it in this example, let's talk about how does a product engineering team deploy a website? How do they deploy an API, a code change, right? That is essentially going to be the bar and the journey for our interoperability. And that's everything between the security, the compliance elements, the load balancers, the network ingress, all that jazz. How well does all of that work together? Well, I'll tell you, in enterprises, which are completely predicated on conflict, interoperability is in the negative because of the very nature that the culture is formed. And there's a problem with the strata of these businesses in that you have knowledge silos. And again, all of this stuff I'm saying probably doesn't sound like anything too profound, but when you start thinking about how this really impacts organizations that are moving in a cloud native direction, you start to see that it actually creates a schism and almost like a dam building up pressure behind it with people wanting to deploy. You start to get lots of conflicts internally. So I drew this very basic diagram, and I hope this sort of illustrates the basic camps you have at any large scale organization. Now, I'm not going to put names to this, but this is fairly representative of a basic setup where you have separation of concerns in terms of lines of business, but more distinctly, you have separation of concerns within technological organizational units. So CI/CD teams, SecOps teams, so on and so forth. This is an example of when you work at a large company, you would probably have to talk to all these various teams through some sort of ticketing system, an ITSM. Even if you want to deploy that React package, I bet you probably have to talk at the network ingress team at some point, or perhaps even someone running converged infrastructure. And these are little pockets of power who act as gatekeepers, and this is no good for anybody. So behind the scenes, what's actually going on here is that you have a lot of different processes that are happening to get to production, and a lot of different flows and concerns. And the philosophy behind enterprise interoperability is to reduce the complexity of these flows. So this is a relatively simple example, but you can already see there's a lot of arrows and a lot of boxes here, which essentially mean that there are things that need to happen in order for your package to get deployed out to the real world. And so as part of simplifying this topology, we need to create ubiquitous and commonly accessible APIs. And so Kubernetes, great, that's one piece of the problem solved, but it's not all the problem solved, because to exclude non-cloud native, so traditional services, mainframes, existing landscape, is folly in a large-scale organization when you're trying to get buy-in. And so what we decided was the mission statement should be the following. We want the developer experience in an enterprise to feel like that in a startup. That was a really good mandate, because that gave us the idea of, how do we start to think about taking this huge problem that's like staring at the sun and breaking it down into something that's simple and can be itemized and attacked in different parallel activities. So when you think about your inventory of considerations here, you have to think about your existing ecosystem. You think about the services and systems, their varying levels of maturity, the security concerns that may overlap but are not always the same, right? You may have SecOps teams operating within several of the lines of business in a horizontal fashion, but you will also find security teams in an isolated silo, in a vertical fashion somewhere else in the business. So they don't always have the same, SVPs or whoever it might be they're reporting into, and therefore there's by nature competitive activity going on there. And so as part of moving to more of this startup model, we also want to change the culture at the same time. And believe it or not, I think you can do it if you introduce one of the CNCF's latest adopted projects, Open Policy Agent. So it's a bold statement to say you can do all this with OPA, but I'm going to talk to you about some of the activities we've started to put into place and some of the outcomes we're starting to see. But before I do all of that, I want to tell you what OPA is. So OPA is essentially a policy decision-making engine, and it reads files and it gives you an outcome, right? So the idea is that when your software needs a policy decision make, it queries OPA, right? It queries OPA, it supplies structured data like JSON as an input, and then OPA takes any sort of arbitrary structured data, and then it will give you an output, sort of a binary yes, no, this can proceed. I mentioned it's a CNCF project. It's incubating currently. There are a few different bets on, but OPA is extremely prominent because of the capabilities that are provided by DAS. I'll mention that a little later on, that allow an enterprise layer on top of this, but also because of the strong community and reusability around OPA. And I'll go into talk about what do I mean with all this a little bit now. So first and foremost, OPA is declarative. It has a policy-aware context. It's extremely fast. It's portable. So it's based on what's called a RAGO. A RAGO is a file type that was inspired by Datalog, and data log was essentially extended and restructured to support modern document models such as JSON. Rego queries are assertions on the data stored in OPA. And these queries can be used to define policies that enumerate instances of data that violate the expected state of the system. And so in my very simple Silicon Valley reference, which is actually straight from the Rego playground, you can see how this might work, right? This is a function-like block of code. It says, okay, well, if there's a certain label or there's a certain, in fact, there's a variable defined image, which is based off the YAML spec of the admitted object. If that starts with huli.com, don't allow it. In fact, it's the inverse. If it doesn't start with huli.com, don't allow it. And so this is already game changing, because you're suddenly thinking, wow, as a security engineer, I don't have to tear my hair out trying to build some custom Jenkins Groovy library thing that scans images when they get deployed. So at the outset, it's extremely interesting. The second thing that's really awesome is that there's a first-class integration with Kubernetes called Gatekeeper. The thing is, OPA is not explicitly built for Kubernetes, but Gatekeeper enables it. OPA can be combined with Envoy, and that's exciting as well, because by combining OPA with Envoy, you can do some very cool stuff. Now, when it was combined with Gatekeeper in this integration, you got a couple of things out of the box. You got the ability to have CRDs for OPA. So you've got constraint templates. And I'm going to go into what all this means, but essentially you can templatize your library and you can share these around, right? So one engineering team is using a particular set of constraints. You can do a kubectl apply on your local machine. If you've got OPA running, a kubectl apply in your namespace, if you're running in a dev environment, and replicate some of those wanted constraints. You could be a developer doing it. You could be a SecOps engineer doing it. You could be the SRE or the cluster operator, making sure that that cluster is always running the huli.com check, right? Now, back to what I was saying about Envoy, OPA also supports WASM. So if you're not familiar with WASM, it's WebAssembly binary instruction format, which is a stack-based virtual machine format, which is developed sort of C++, C, Rust, and all those sort of languages that enable you to deploy on the web for client-server applications. And this is super exciting, and it's very new because WASM filtering in Envoy with OPA enables you to do super low latency and low cost checks. That is interesting because it means that you can call it from a web client. And here I'm just showing a little excerpt from Vue.js where somebody is actually initializing a Rego and then actually serving it. So there's an interesting future there. And finally, as I mentioned earlier, DAS, so Declarative Authorization Service, is the enterprise ready and sort of the supported way of how you can scale this out with a visual GUI. You've also got the ability to codify repositories of policies and share them around. And so from an enterprise perspective, it's extremely exciting because you've got something with support, you've got something with a flashy UI, and everybody loves a flashy UI if you're an executive. So all that said, and all those great things I've said about OPA, I'm going to just do a micro demo. And it's a micro demo because it essentially comprises of me doing a couple of very basic things. So please shout if you cannot see my terminal, or I'll keep going. Yep. Okay. So I've really boomed it up here so you can see it really simply. So first and foremost, we've done a little grep here, and we can see the out-of-the-box custom resource definitions. So these are extensions to the Kubernetes API that you get out of the box with OPA. So OPA-Gatekeeper, I should be more precise. Here you see, as I said, you've got this idea of a constraint template, constraint pod status, etc. So let's actually look at what is a constraint template. Well, we go to our Kate's label constraint template, and I'm not going to walk through this entire file, but I will show you the interesting bits at the bottom. I've got a very obnoxious colored Vim background. I don't know why this is, but it's quite suitable for this talk. So as you can see here, the Rego actually targets the package, and then it has an implementation of the policy. So this is the violation, a bit like I was showing in the first slide, and you can create this as something that is callable as a template. So that sounds a little vague. So what I mean by that is I can create this Kate's constraint label constraint template, And then as a cluster administrator, let's say that out of the box, my cluster ships with all these constraint templates, but I might want to turn them off or on. And this might be familiar to people who use OpenShift, because OpenShift has a very similar kind of governance methodology that's just been applied to it. Well, let's pick one for namespaces. So what I'm going to do is I'm going to use the label of gatekeeper, and I'm going to say that it's using the Kate's required labels kind. And this is important because that matches the template policy that I have. And what I'm going to do now is I'm going to take that namespace. In fact, before I do that, let me just show you. I go Q-control create ns whatever temp1, right? Shouldn't have any problems. Now let's apply that namespace constraint. And what we should see here is that once that applied, I can go and run a cool. Let's create something else. So we'll go Q-control create ns temp2. Oh, and it says, oh, you've got to provide a label. So what we can see is that policy requiring the parameter of label is now part of the object of mission check. Now let's just go back and understand what actually happened there. So if I open the Kate's file again here, you'll see that in the violation, it requires label to be provided, and label has to match in this YAML file of parameters. So if that label doesn't exist on the admitted object, then it's going to kick up a fuss. So that's the 10-second demo there, or 2-minute demo, that hopefully shows you some of the power, because instantly it's blocking any new object admissions. Now, I'm talking about object admissions. Let's dig into why this is interesting, what an object admission is, and where this goes from here. But first, let's just identify that, OPA is really helping us to create a new type of self-service experience. As an engineer now, I am dictating what's going into a cluster, which usually used to be the exclusive right of somebody who had RBAC permissions in that cluster. I can now control, if it's been delegated to me, what I can have go into my namespace. I can run my own microservice architecture in a tenanted cluster in my own namespace and say, okay, well, you folks can do this, but you can't, and you people can do this, and be way more high fidelity than RBAC is on its own. So a whistle-stop tour of how this works, just conscious of time, is that you have an object submission. That object submission is when you would do and sort of create some YAML and post it to the Kate's API server. OPA Gatekeeper hooks in at the admission review phase. So in that pre-creation phase, the policy will be challenged, and that challenge will do a check and then give an admission response. And then that will go downstream to the controllers, right? And then in our case, we can start thinking about, well, what if the controller isn't just a create pod or a deployment manager? What if that controller is a custom resource definition controller, and we can do some other things? That's when things start to get really interesting. And that's when we start to be able to think about solving some of these enterprise problems. Because what we can start to do is say, well, I've got this ability to suddenly set very high fidelity policies. I've got this ability to create CRDs. I've had that for ages. I can express what I want to do. And I also have this now newfound trust that when an object is created and given to the operator, it's already gone through all the authentication and authorization and back-end checks. So the operator can just perform the reconcile loop. What that means in plain English is the following. You have the ability for this new model of a bring your own service, where people not in the Kubernetes club can start bringing their services into a Kate's environment by writing their own operator. So the kind of analogy I would give here is that if you run a mainframe or you run a big IP F5 load balancer in a physical data center, those things aren't necessarily just going to have a Kate's operator you can plug and play, or have an underlying controller that's applicable for them. However, now what you can do is write your own Kubernetes operator using KubeBuilder or something. You can integrate with your old-fashioned API. It might take 2 requests a minute, but your operator inside your cluster can control that. And then you can allow your tenants within the cluster to start saying, hey, I want to provision one of those. So that's a lot of stuff to think about. I'm going to show you it and break that down, what I really mean by that. So let's think about F5, right? So an F5 is a form of virtual IP, right? So a VIP. This is a super hypothetical example YAML file, but it is the kind of thing I'd expect to see. So you would have the desire to set a host name. I've put a domain name, but it's academic vernacular, TLS termination, etc. And you've got a target for the internal cluster service endpoint. So hypothetically, this YAML could mean something like, I want to provision a VIP within the corporate network that will route to my cluster, and the CNAME is going to be set for this domain. There's a lot of information here. Now, I could just go off and create my service operator, and just provision a VIP and then come back again. But the problem here is that, there's a bunch of stuff that I haven't validated. And also there's a level of due diligence that hasn't been run, right? Cost center. I know it sounds petty, but everything has to be traced back to cost, especially in large financial organizations. Being able to check that cost center as part of the policy, if it exists, and if you have the authorization, is super important. Being able to take the current service account user, run that user against an Active Directory backend, and check if that user has permission is also important. And these are the start of things that we're able to answer with OPA. And as complex as that sounds, if you get that bit right, you can just federate that out, and people can start creating different types of service operators using the same labels and using the same annotations, and enabling people to bring Lego bricks into the cluster from their services that are outside of the Cloud Native Cool Club. So let's think about what really enables that. Well, that's because OPA supports two things. It supports plugins. It's written in Golang, so it supports plugins, but it also supports extension of the built-in functions. Extension of the built-in functions enables some super interesting stuff. So Active Directory data management is centralized because you need to have strong consistency, flexibility, and verification. But in here, we're enabling policy enforcement to be done through OPA, through our distributed Kubernetes clusters. You could have 2 tenant clusters, you could have 100,000 tenant clusters, it doesn't matter. But this ensures you have super low latency, high availability, and strong policy enforcement. Any data changes in Active Directory, in this little example, will be published and distributed to the OPA instances dynamically. Now, in this example, again, this is a pull sort of style where somebody runs a object admission, the OPA agent runs a function, that function does a post request, does a get, checks something, but you could easily do it in some more sophisticated method. When all these things come together, the extensions, the policy, the operator, you get this kind of system. And let me talk you through it. So remember that diagram right back at the beginning, that little illustration of the complex Disney castle and the different forts. You have something that looks a lot more like this. It's a sequence. It's like a sort of a car production line now, in that you have your CRD. This might be saying, hey, we're an engineering team. We've had something in dev. We want to promote it to the next environment and get an ingress for it. You create a CRD for that. You look up on whatever it is, Confluence or other godforsaken CMS, and you say, okay, right, this is how the notes say to do it. That's great. You then commit that in. Hopefully you'd have a GitOps process that would then pull that into your cluster. OPA would then go through the admission phase. Now, in this example, we have two groups who are interested. We have cloud provisioning policies, which comes from our private cloud team and SecOps, and we have business intelligence who want to make sure that I've got the right labels on my workloads. And here, again, as I mentioned previously, what would happen is the cloud provisioning policy would be based on the fact that you have packages for the cloud provisioning module and the ADS module. So what I mean by this is, let's take an example. If I request not an F5, but if I request that when I create this CRD, I can have access to, let's say, additional ports on the node if they're locked down. And the cloud provisioning module team would go off and check your ADS. They'd also check that that request had been fulfilled. And what you start to see here is that naturally there's a reuse, right? Because the cloud team have got that module. So next time down the road, the CI/CD DevOps team might also want to leverage that. And this is where it's great, because there's reusability everywhere, right? You can do it at the Golang level, at the modules and extensions of the functions. You can do it at the policy level, and you can even do it at the service operator level if you have very many similar services. So we found that there are sort of 3 key benefits, and there are 3 key observations that we made. So benefit and observation is that high performers, companies in general, have high interoperability. This is, it sounds obvious, and it's the inverse of the graph I was showing you earlier on, but more joy is generated when you have high interoperability, because it usually denotes there's higher automation within an organization. The second part is that Open Policy Agent integrates into developer workflows and provides simplicity and reusability. This was something that actually started to gain traction after implementation, not during or before. And the reason being is that it takes a bit of time to create an ecosystem. And what happens is you start to garner a bit of a grassroots approach where engineers will say, okay, well, do you have a policy for this? Or who is it that's making me enforce this? Why do I have to have this when I create my template? And then you start to see that they become hubs of activity where you'll get repos that are gravitated towards, or people want to contribute to, so that policies are shared and understood. It also is a godsend for SecOps teams who are, trying to understand things, complex behaviors such as the way that Istio works or Linkerd or other service mesh, are now able to actually take all of that and underline it with a simple policy matrix. And so therefore, I've seen people are really championing this as a way of really reducing the overhead involved when making policy decisions on an individual service. Because if a service automatically adheres to policy decisions by running OPA test on their local, and they can pass all the policies of their service, it makes those teams feel a lot more confident before they deploy them out. And thirdly, cluster policy engines can control service access, enabling self-service. And this is just really, again, to hit home on the previous point, that once you have this in place, you can start enabling people to bring their own operators to the table from the mainframe team, from the F5 load balance team, from the converged infrastructure underlying storage team, to say that here is what we want to bring, here's our policy, here is our service operator, and here's our CIDs. This is how we want people to use it. This is how we're going to manage it. And again, just to segue slightly, there is another benefit here in that these teams are gaining vital Golang Kubernetes experience and being brought into that cloud ecosystem as well. So you're really aligning the whole technology organization on this sort of pathway together to start to bring all of your technological services together. So very quickly, lessons learned. Well, lessons learned are that you can't go big bang on this. People like to make small bets, especially with new technologies. And therefore, you need to go very narrow, but very deep. So have one use case that works really well. This idea of taking an F5 or a Cassandra node, like having a Cassandra cluster that you can just, spin up, even though it might belong to some other team. That's a great example, or Kafka or something like that. We learned that, this is still a work in progress. It's got 1 million miles to go, but the things that are going to be really key to succeeding are the developer feedback, sort of notes on how they're getting on with this and how they're enjoying interacting with this, but also how is it starting to change the internal culture, and how is it starting to put DX in the driving seat. Finally, if you'd like to learn more, I've written a bunch of articles on this. It's a complex subject. It's interesting. Interoperability in technology organizations is a big thing right now, and it's a problem and a sort of a mountain that many people are trying to climb in different ways. So there's no means a set menu on this. So let's see where it goes. And by all means, please reach out. And that's me done. Thank you.
Fantastic. Thank you for that, Alex. That was a very interesting take on OPA, because when I first heard about OPA at KubeCon, it was always discussed more from the terms of microservices, which microservice can talk to the other one, kind of like an internal firewall. But around the provisioning side, it was definitely a different use case that I hadn't thought about. So thank you very much. That was interesting. Couple of quick questions. Walid Shari says, if you use Gatekeeper, you will not have access to the mutating admission. From your experience, why should we use Gatekeeper if OPA works directly with K8s anyway?
Yeah, that's a good question. I think that, in honesty, it rides on that theme of DX, in that Gatekeeper, by allowing you to work with templates, gives a lowest common denominator of YAML files for engineers to work with. I think it's also interesting to think about a lot of people who set up tenanted clusters. So they're working as a tenant within a cluster will simply have these things applied automatically and won't necessarily be writing Rego policies. But I think also that there is an opportunity for Gatekeeper to distinguish itself a bit by breaking down some of the OPA components into more Kubernetes-based resources. So for example, one of the limitations of OPA at the moment is that you have to compile it. You have to recompile it when you want to put new built-in functions. And that is a bit of a pain. and it means you need new binary, new images, etc. It would be very interesting to see if Gatekeeper could take that a step further to use almost like a DSL, where you could write built-in functions within Kubernetes resource types. So I think there's opportunity to improve the DX in a more Kube native format.
Fantastic. There was a question which has come through privately about, can we have your Twitter account and a link for the article?
Yeah, will do.
That's been answered, but what we'll do is if we can put that in the community Slack for anyone that's interested in it after the talk, that would be great. And finally, do you see OPA or another admission controller becoming a default on setting for Kubernetes, with terms like DevSecOps and even SecDevOps being thrown around, showing that security thinking is at the forefront of more people's minds? Do you see admission control becoming a part of Kubernetes out of the box?
My personal take on this is actually to go the other way. I think that Kubernetes is trying to boil the ocean a bit in that it has so many features and functionality now. We almost need to have an enormous flagging system that when you spin it up, you don't get all this stuff enabled. I think that in certain spins, like I was just looking at Capital One's critical stack the other day, that it makes sense to have like almost spins of Kates that have it enabled. As to whether I think it will be on mainline, I would doubt it, because it introduces an overhead that not everybody wishes to pay. And equally, I think that there are still, it's a fledgling kind of use case still. I don't think that every developer across the world wants to suddenly have a policy enforcement built into it.
Yeah, I agree. Okay, so that's the end of the specific questions on that. Thank you to all of the guys for the talks. We've got a few questions which may be more generally applied. So Ayan Satomi, I still don't know whether it's a yarn or a yarne. You've attended every talk and I still don't know how to pronounce your name. Hey Civo, does that mean we're getting dedicated ML instances like VMs with shared GPU access to an NVIDIA GPU? Our CEO constantly talks about how he wants to put GPUs into our clusters. So as CTO, my answer is we don't have any current firm plans to do so. But if Mark gets his way, he's going to keep bringing it up every so often, and we'll find a way to get it in. If nothing else, as kind of an experimental add-on. If you want to have a play with GPUs, then there's a way of trying it so that we can see if there's much use for it. If you're interested in that, maybe someone start a thread in the community Slack so that Mark can see the sort of the interest in it, and then maybe we'll talk further about that in the new year about adding that. Ayana also said, we've mentioned Kubeflow here, but we don't have this as a marketplace app. Perhaps we could have it in the marketplace as a community effort, or would it be provided by Civo? Well, it's funny you should say that. Saiyam is actually in charge of the marketplace now, so we can take this as a suggestion to him, or definitely if anyone wants to submit it as a marketplace app, that's an open marketplace. Anyone can submit a PR. It's documented. It has some relatively simple tests, and we have some videos on our YouTube channel about how to add applications to the marketplace. A specific question for Saiyam: how did you deploy Keyflow? It says this is from Sana Omar. I assume it's Kubeflow.
Yeah, it's the documentation. We just follow the docs of Kubeflow, fairly simple, so you can deploy. And if you have any issues deploying to Civo, then I can help.
Fantastic. So yeah, Sana, reach out to Saiyam in the community Slack if you have any questions. If you post in Kubeflow, we have a great community that may be able to jump on and help as well. Next, the one quickly, we'll go back to OPA first. So Alex, how does this perform against other authentication and policy systems? Google, for example, employs a zero trust authentication and security system. How does this compare to this project?
Yeah, so the Google implementation of, I believe it's IAP, if I recall correctly, it's been a little while since I've used it, is pretty awesome. There are a couple of different features with that, right? So it also gives you the IDP component, and it also gives you the IODC, so the open identity connection capabilities as well. I couldn't say for certain how it performs against it, because primarily this was orientated towards a hybrid cloud, quote unquote, and on-prem use case. And that maybe punctuates part of the problem, is that there aren't enough projects to be able to really run a full comparison against. But the point around WASM filters, I was saying in OPA, is extremely lean. The way we were actually looking at that, where it was against some of our more proprietary systems that look at actually do an API call out every time they want to do a policy check, and it's light years faster. So I apologize, it wasn't a particularly concise answer, but that's where we are.
Fantastic, thank you. And then the final question we have, if anyone has any more questions, feel free to get them into the Q&A section at the bottom of the webinar. I think I mentioned before that most providers have some sort of RWX read-write many volumes on persisted shared data. Civo does not support RWX at the moment, so what's the approach here, since we may want to optimize volume usage by sharing volumes across workspaces? You're right, we currently don't have a solution for that, but we've partnered for our new platform with Storage OS, and the latest version of Storage OS now does support read-write many. So we haven't yet worked out how we could surface this up to customer K3S clusters, but given the fact that our underlying storage platform now supports it, there's a chance that we can proxy through, if you like, to that functionality and offer that into client clusters. So at the moment, you're right, we don't have RWX. Hopefully it is coming. The approach without it, I guess, would be to run an NFS pod somewhere with normal persistent storage and use the NFS mounts to multiple pods. I don't know what the answer is though, unfortunately, other than that.